the table because we're gonna, or underneath the graph, because we're actually going to use it to plot. So here's Raymond starting. Let's say that he starts off with $1, okay? And Grandma triples that to get his reward. So 1 times 3, that's where you're getting 3. Then let's say he starts off with $2. Well, if I triple it, 2 times 3, my reward from Grandma is $6. If I start off with $3 and I triple it, 3 times 3 gives me 9. If I start off with $4 and I triple it, 4 times 3 is 12. And then again, if I start off with $5 and I triple it, I'm going to get $15. Okay? So input, output, input, output. All right, so again, my rule is the same rule that it's been. It's going to be my starting number, okay, times 3, which will give me Grandma's reward. Okay, I haven't changed that. All right, so now what we're going to do is we're actually going to plot this on the actual graph. All right, and you've never done this before, so I'm going to show you an example of what it's going to look like plotted on a graph, because we've never actually taken an input-output table and actually graphed it. Okay, so let me show you my copy and my version of it so you can see exactly what I've done, because I want you to be able to do the same thing that I did. All right, so here's my bigger version. Okay, so you can follow along with me on yours. I told you you have 2 axes, okay, and that's very important. Do I label this Y? Do I label this Z? Do I label this Z? Do I label this Y? We don't know. So I'm going to kind of help you through that. Remember, we said Z is represented by Raymond's starting number. So Z is going to be represented on this axis here. And Grandma's reward is going to be on this one here, okay? So do that now. All right, remember we said that on our table that Z, we're using the starting numbers of 1, 2, 4, 5, 6. So we have to show that down below. So I'm going to go 1, 2, 3, 4, and 5. Okay, and then over here, we showed our Y, and we went ahead and showed all the way up to 15. So again, if I'm counting by ones, I've got to go up to 15. So I'll give you a minute to do it. I'm going to do it too on my Y. I'm going to start at 1, and I'm going to work my way up to 15. And you can do the same. So there's my starting, and then eventually this is going to be my reward. All right, so now I'm going to actually plot this. If I have my starting was 1, I times it by 3, I'm going to get 3. So watch what I do. My starting was 1, and then when I times it by 3, I'm going to come up and I'm going to draw a circle and I'm going to plot. If I have a starting of 2, I'm going to go up 6. So I'm going to come over. There's his starting amount of $2. If I times it by 3, I'm going to go up to 6. And I'm going to plot. Hopefully you're starting to see a pattern. If I have a starting of 3, I'm going to go to 3 and go up 9. So I start at 3 amount, I times it by 3, I go up to 9, and I plot. Okay, go ahead and do the last 2 by yourself. Do my $4 to $12 amount, my $5 to $15 amount, and go ahead and plot it on your graph, please. Okay, you should have had 4 going up to 12. And then you should have had 5 going up to the 15. Okay. All right. So the information that is in or on your input output has just been transferred so you can visually see what's happening every single time. Okay. You can kind of understand that you're increasing on your input output table, but on a graph, it's a really nice visual to really see the increase that's taking place every time you triple the amount. All right. Now we're going to use this graph to kind of answer a couple of questions. So flip to the back. You're going to see this little half sheet on yours. And at the very top, it's going to say, how did you represent your data? How did you label the axis? Okay, so again, notice that we represented the data using a Z and a Y. Okay, so how did we label it? This is what we're going to say. We labeled, and we didn't use X. I'm going to have to change that. We use Z. So we used Z here to represent raise money. That Y-axis we use to represent raise money after the reward. Okay, so that is how we represented our data, and that's how we labeled the axis right there. So make sure you put that in there. All right, then the next question says, could more points be represented on your graph? Okay, if you look at your graph, so it's saying, could I add more to it if I wanted to? Okay, you should be thinking, yes, I can add more points. So we're going to say, yes, more can be represented. Okay, absolutely, I could add more to my graph if I needed to add more to my graph. So yes, more can be represented. Then the question asks, how far can you extend your graph? So how far can it keep going? Now, if I physically look at the graph, yes, we know it's going to stop here. But let's pretend that, it can keep going off the page. If I wanted to keep going with this graph and I had enough room, I could go off this page. Okay? So we're not going to say, no, it's going to stop. No, this graph, if I could extend it, it could. So this is a continuous graph. So we can say it's continuous. Even though I can physically look at the graph and see a stopping point, if I wanted to create that amount and even go past his starting number, let's say his starting number was 40, I could represent that. Even though I don't have enough room for 40, I could extend it if I wanted to. So it's continuous. All right, then looking at D, it says, suppose Raymond counted his money after his grandmother gave him his reward. He found he had $60. How much money did he start with? How did you get your answer? So this time you're having to work backwards. You know that grandma's reward is $60. We have to know what his starting amount is, okay? So for D, you should be thinking, okay, well, if I'm going to work backwards, I'm going to say 60 divided by 3. So his starting amount would have to be $20, okay? And then the question will ask you too, how could you use your table to get your answer? Well, I could extend my table. Z is 20. 20 times 3 gives me 60 if I follow that rule. All I'm doing is extending whereas I started off with a 1, 2, 3, 4, 5, I would have just kept going, 6, 7, 8, 9, 10 until I got to 20, and I would have just kept applying that rule. Okay, and that kind of goes with our next question, because our next question says, how could you use your rule? Well, this is your rule again. Z times 3 equals Y. You're taking the starting amount, timesing it by 3 to give you grandma's amount. And then last it says, how could you use your graph? Well, once you figure this out and you have your rule, okay, you can display this on the graph. You just go over 20 and up 60. All right, so again, you would just, you would plot it on the graph. We stopped at 15 on our graph. I could keep going up to 20 and I could extend it up to 60 if I needed to, because we all agreed that this graph is continuous. it's going to keep going. All right, this concludes LEAP lesson 13. So when you finish this assignment, make sure your name's on it and you'll give it to the sub, and then she will tell you your next set of directions.